Let's take a look at this example. Okay, so this is my node. Okay, this is the point at which these currents are going to meet together. You're supposed to realize that the sum of the currents which comes and leave the node is always equal 0. That's why I'm going to write that I R1, okay, plus I R2 plus I R3 plus I R4 plus I R5 is equal 0 amps. Okay, so we have 0 amps over here. So we are looking for current I. In order to find I, okay, I supposed to simply find the current IR4. Okay, so let's use this formula. So IR1, okay, because the current is coming to the circuit, I'm going to write that this is 7 milliamps. Okay, now we have plus the current IR2, which is leaving, so I have negative 5 milliamps. Okay, and I have IR3, which is plus 2 milliamps. Okay, and we have plus, okay, I4, we don't know, IR4. And we have plus IR5, so I have plus 4 milliamps. And of course, everything must be equal 0. So we have 7 milliamps minus 5 milliamps, okay, plus 2 milliamps plus IR4 plus 4 milliamps is equal 0 amps. Okay, so this is my equation. So next, let me organize this equation a little bit. 7 milliamps minus 5 milliamps is equal to 2 milliamps. 2 milliamps plus 2 milliamps is 4 milliamps, and 4 milliamps plus 4 milliamps is 8 milliamps. So I have IR4 plus 8 milliamps is equal 0. Okay, so I'm looking for IR4, that's why I'm going to move 8 milliamps to the other side. So I have IR4 is equal negative 8 milliamps. So I can say that IR4, okay, is equal I, okay, on my diagram, and this is equal negative 8 milliamps. It means that this current is leaving the node, okay, it's leaving, is going in this direction. Okay, and this is the solution to my problem.